Hi, in this video I will show you how loop invariants are closely related to recursion. This is where we finished last time. It's a function that finds minimum number in an array. So far we wrote it using iteration, but it's very easy to turn it into recursion. First we need to identify all the variables that change throughout the iteration. We need to turn them into function parameters. Now we can reduce the while loop into a recursive call. Instead of while, we turn it into just the if statement. If it's true for the next index, then we continue the recursion. Otherwise, we terminate and return the result. Notice how those assertions stay the same. Nothing changes here. The only thing that we lose are the loop invariants, because we no longer have any loops. Now this is almost finished and it's almost correct. The only problem is that OpenJML is not able to reason about the assertions in a recursive function. We need to turn those assertions into a precondition. Just like before, we turned the assertions at the end into postconditions. Now we can take them and replace the assert keyword with requires. Now such a function is a well-specified recursion. As you can see, OpenJML was able to correctly prove the recursion. Preconditions are not only useful in recursive functions. Using preconditions would also be beneficial in this iterative code that we had at the beginning. Notice how something looks a bit off. Here we use 1000 as the initial value. If the array is empty, then we will never enter this loop and we will just return 1000 every time, even though it clearly isn't the minimal value from the array. The specification we wrote so far is correct because we only demanded that the result is smaller than all the elements in the array, but if the array is empty, then there are no elements to disprove it, so this statement holds vacuously true. We would like to avoid this scenario. One way to do this is by adding a precondition. This will demand that the array is not empty. Every time somebody tries to call this function, they will need to first prove that the array is not empty. If they cannot prove it, then OpenJML will throw errors at them. I hope you liked this short video. In the next one, I will show how to cheat the system and how to prove something that is clearly false.